Welcome to the Chapter 8, Part 2 video. We're going to be looking at simplifying rational expressions, very similarly to how we did in Section 1, but then we're also going to be looking at how we can use those same steps to multiply and divide rational expressions with a few additional steps. So the first thing that we want to do is simplify. Now, this is the same as what we were doing before. We're going to factor, and then we're going to see if there are any factors that reduce. So in our first example, we have x divided by x squared. Notice the x squared can also be written as x times x. So I'm going to write it out that way. X divided by x times x. That makes it extremely clear here that we can simplify and remove an x from the numerator and denominator, leaving us with 1 over x. Notice x cannot be 0. That is what we removed. Okay, but x still cannot equal 0 in the denominator. So if there are two types of discontinuities at the same value, the non-removable discontinuity kind of wins. It overtakes the removable discontinuity. So this would still have an asymptote, and essentially that asymptote would be removed with another asymptote. Okay, so the graph here would still look like this, where we have the same asymptotes as before. Okay. In our second example, we're looking at 3 times the quantity of x minus 3, all divided by x minus 3. Just like I mentioned in class, I'm going to group together the denominator so that it's very clear what we can and cannot cancel. If there's any addition or subtraction, it must be put into parentheses before we can cancel. So since I have a group x minus 3 in the numerator and denominator, those can reduce, leaving us with 3 over 1 or 3, but x cannot be 3 because that was removable. That's our removable discontinuity. Okay, and then lastly, our example here, we have x squared minus x minus 6 over x squared plus x minus 2. We want to factor. So I need two numbers that multiply to -6 and add to -1. That's going to be 3 and 2 with the bigger one as negative, so that when I add them, the result is negative. I'm going to double check. -3 times 2 is -6. -3 plus 2 is -1. So that gives us our numerator of x minus 3 times x plus 2. For my denominator, I'm going to do the same method. Two numbers that multiply to -2 and add to 1. That's going to be 2 and 1, but this time I want the smaller one to be negative, so that when I add them, the result is positive. 2 times -1 is -2. 2 plus -1 is +1. So that means my factors are x plus 2 and x minus 1. Okay, I'm looking at this, I see there's a quantity of x plus 2 in the numerator and the denominator, so those will reduce, leaving me with x minus 3 divided by x minus 1, where x cannot be -2 because that was our removable discontinuity. Notice that x equals 1 is still a discontinuity. This one is a non-removable, which means that this is a vertical asymptote. Okay. So that's how we simplify into simplest form. Means we cannot simplify anymore. And in order to write it in simplest form, we need to factor. That's our big key for rational expressions. And we'll see that we still use that for rational functions in the next section. Okay. So I want you to try this one on your own. Remember, the key here is to factor, and then remember to state any restrictions just like I was doing. If it was removed, it's still a restriction, okay? And then we'll look at it together. So in order to solve this, we need to factor the numerator and denominator. I have the factors written here, and then we want to simplify. Are there any common factors? They both have a factor of x plus 2. However, the x plus 5 and x minus 5 are different values, right? Think about if x was 3, then 8 divided by -2, they're not the same number. Okay, that doesn't mean it won't simplify when I substitute a number in. However, it won't always simplify when I substitute a number in. So our final answer is x plus 5 divided by x minus 5. We cannot simplify that any further because addition and subtraction always has to be written inside of parentheses before we can start canceling. Okay, and then the restriction that we removed is that x cannot be -2. So I'm stating that as a restriction so that I don't forget that that is a point of discontinuity. And in our case, it is a removable discontinuity. Okay, so then let's take a look at writing the same process, but with multiplication. And the nice thing about multiplication, when I multiply fractions, I just multiply across the numerators and I multiply across the denominators. So when we're looking at this, our first step is still going to be to factor. I'm going to look at my first factor here, my first fraction. Two numbers that multiply to -6 and add to 1. That's going to be 3 and 2 with a larger one that's positive. 3 times -2 is -6. 3 plus -2 is +1. So that's x plus 3 times x minus 2 divided by x minus 5 doesn't factor, so we just write it as x minus 5. I'm putting it in parentheses so that I don't accidentally try to cancel a term instead of a factor. Addition or subtraction always has to be written inside of parentheses before we can simplify. Times x squared minus 25 is a difference of perfect squares, so we write that as x minus 5 times x plus 5. For my denominator, I need two numbers that multiply to 3 and add to 4. That's going to be 3 and 1. So we have x plus 3 times x plus 1. Okay, now because this is multiplication, the numerators are going to be multiplied together. And since parentheses means multiplication, I can essentially ignore that multiplication sign and write it all as one big fraction. Okay, so I'm going to write that in a second line so that we see where it comes from. X plus 3 times x minus 2 times x minus 5 times x plus 5 all over x minus 5 times x plus 3 times x plus 1. And now I don't want to multiply all of these out. What I want to do is simplify. And to simplify, I'm looking for what factors are in both the numerator and denominator. So notice I have an x minus 5 in the denominator and numerator. I also have an x plus 3 in both the numerator and denominator. Okay, and then I'm going to check, is there an x minus 2 in the denominator? No. Is there an x plus 5 in the denominator? No. Is there an x plus 1 in the numerator? No. By doing that check, I've made sure that I've simplified as much as possible. So I factored completely first. I wrote it into a single fraction. Rewrite. And then finally, simplify. And so my final answer here is going to be x minus 2 times the quantity of x plus 5, all divided by the quantity of x plus 1. And I'm going to put my restrictions. What canceled out? X cannot be 5. X can also not be 3. Oh, -3, because x plus 3 is 0 when x is -3. Okay, so this is my final answer here. I have my function in simplest terms, and I have my restrictions. Okay, I have one for you to try, and then we'll go through it together. Okay, so in our first fraction, we can factor the numerator. We can factor out a greatest common factor of 2. The denominator is a difference of squares. And then in our second fraction, we're just going to factor the trinomial using whatever method you want. Okay, we write it all into a single fraction and we can reduce. I have a factor of x minus 4 in common in the numerator and denominator. That factor is now gone. I have a factor of x plus 4 in the numerator, and I actually have 3 factors of x plus 4 in the denominator. I can only reduce one of them. Once I cross out the x plus 4 in the numerator, it cannot be reused. Okay, so it's not every x plus 4 in the denominator that gets reduced, just 1 in the numerator and 1 in the denominator. If there were 2 in the numerator, then I could simplify 2 in the denominator. So what's happening when we cancel these out is that this is turning into a giant 1. And this is turning into a giant 1. So it can't be reused. It's already been reduced. Okay, so our final answer here, 2 times the quantity of x plus 1, all divided by the quantity of x plus 4. I've got 2 of them, so I can write it as squared. Okay, x plus 4 squared in the denominator. And then the restrictions that I had, I reduced by an x equals 4 and an x equals negative 4. I can write that in compact form as x cannot be positive or negative 4. Okay, so that's multiplication. The other topic that we had on our objectives list was division. And the key here, if you remember from the introduction to the chapter, when we do division, we have to use the reciprocal. So we can call it keep, change, flip, where you keep the first fraction, you change it to multiplication, and you flip the second fraction, or you can call it the reciprocal. Okay, so I'm first going to rewrite this as multiplication. And then we're going to do all of the same steps we just did for multiplication: factor, rewrite, and simplify. So the first fraction stays the same, 2 minus x divided by, and I'm not even going to factor first. Once you're comfortable with this, you can start factoring while you rewrite. But first, I just want you to see where all of these numbers are coming from. So I'm not going to factor anything while I do the keep, change, flip. Minus 10. Okay, so all that happened, the division becomes multiplication, and the second fraction flips. First fraction stays the same. It's always the second one that flips. Okay, now I'm going to treat this like multiplication. So factor, and what I'm seeing here, 2 minus x is actually written in ascending order instead of descending order. I'm going to rewrite it in descending order. So that's negative x plus 2 divided by x squared plus 2x plus 1. Two numbers that multiply to 1 and add to 2 are 1 and 1. X plus 1 times x plus 1 times x squared minus 1 is a difference of squares. X plus 1 times x minus 1. And then our last denominator, two numbers that multiply to negative 10 and add to 3. That's 5 and 2, and the big one needs to be positive. So we have x plus 5 and x minus 2. Okay, now I'm noticing here they're all written in descending order, and their leading coefficients are positive. Remember, whenever we had a leading coefficient, we wanted to factor out the negative. Whenever we had a leading coefficient that was negative, we wanted to factor it out. So I'm going to do that for the numerator. Negative 1 times x minus 2. Notice when I distribute that negative, the 2 will become positive. So I've factored out a negative 1 divided by the rest of my numerator. I have x plus 1, x minus 1, and then my denominator, x plus 1, x plus 1, x plus 5, x minus 2. Then I'm going to start reducing. I have an x minus 2 in both numerator and denominator. I have an x plus 1 in both numerator and denominator. I have an x minus 1 and an x plus 1. Those are not the same thing. So that's as far as I can go. I don't have an x plus 5 in the numerator, and I don't have a negative 1 in the denominator. So I'm going to simplify this. Negative x minus 1 divided by x plus 1 times x plus 5. What restrictions did we remove? We removed an x cannot be negative 1, and we removed an x cannot be 2. So those are our two removable discontinuities. So notice the only change from division to multiplication is that first step. We have to rewrite the division as a multiplication. From there, it's exactly the same. Okay. I have one here for you to try that we will look through together. Okay, so the same steps that we did in the last example, I'm going to change the division to multiplication with a keep, change, flip, or a keep, change, reciprocal. The division becomes multiplication. The second fraction gets flipped upside down. Then I factored everything out, and then I multiplied everything together into a single fraction, reducing any common factors in the numerator and denominator. We had 3 common factors this time: x plus 4 giving us the restriction x equals -4, x plus 1 giving us the restriction that x cannot equal -1, and x minus 3, which gives us the restriction x cannot equal 3. It doesn't matter what order you write those restrictions in. Okay, and our final reduced fraction is 2x divided by x minus 1. You can put that in parentheses. As a matter of fact, I recommend it, so I'm going to put them here. You might notice I put my factor of 2x in parentheses as well, even though there was no addition or subtraction. That's just to help me identify that that is a factor. Okay, I like how it looks better. So you don't have to do that, but parentheses are free, so you can use parentheses anywhere that there's multiplication. Okay, that is it for this section. There's only 4 practice problems here because I really want you to focus and take your time and make sure you're doing these steps carefully and practice factoring, especially, and recognizing when you can reduce factors and when you cannot. So, reminder, if there's any addition or subtraction, it needs to be within parentheses. That way you can factor or reduce. Okay, so factor, factor, factor until all of the addition or subtraction is in parentheses, then you can reduce. All right, if you have any questions, you can email me. Otherwise, I will see you in class.